Like the Stones say, you can't always get what you want. Now, the consumer, by our assumptions of more is better, would obviously like to have an infinite amount of both of the goods. But in the real world, that's not going to be possible. There's limits on how much of each good the consumer could have. The consumer has a fixed amount of money, and they have to use that money to buy those goods. We're going to assume that the consumer takes the market price as given and has a fixed amount of money. So that's going to constrain what the consumer can have. So they can't just have whatever they want, they have to have whatever they can afford to have. So how we formulate what the consumer can afford to have is through a budget constraint. So we've got the prices P1 and P2 for goods 1 and 2, and the consumer has an income Y. So let's suppose that you as a consumer would want to spend all of your income on these two goods, good 1 and good 2. So you're going to pick a bundle, Q1, Q2, that satisfies this equation. This equation is P1, Q1 plus P2, Q2 equals Y. So let's take a careful look at the left side of this equation. If you buy Q1 units of good 1, and the price of good 1 is P1 per unit, how much money are you spending on good 1? Well, you're spending P1 times Q1. If you buy Q2 units of good 2, and the price per unit of good 2 is P2, the total amount of money you're spending on good 2 is P2 times Q2. So the total amount you're spending on the two goods together is P1 Q1 plus P2 Q2. So your expenditure is the left-hand side of this equation. What this equation says is then that your expenditure exactly equals your income. So if you buy Q1 units of good 1, and we know that you're spending all of your income, then that allows us to pin down the amount of good 2 that you'd be consuming. We could just solve this equation for Q2 in terms of Q1. Doing that, we have this expression for Q2, which is Y divided by P2 minus P1 over P2 times Q1. So what this allows us to do is to plot the budget constraint, which is just going to be a straight line with the intercept on the vertical axis of Y over P2 and the slope of minus P1 over P2. Remember, this has this familiar form of, if you're plotting on the XY axis, if you plot a line, you might be familiar with this type of an equation. Y equals C plus mx, where C would be the intercept on the vertical axis and m would be the slope. So here m, the slope, is minus P1 over P2. X is on the horizontal axis, so that's good 1, Q1. Y is on the vertical axis, that's good 2. And the vertical intercept is Y over P2. So we could draw a picture for some given prices and income. So let's suppose the price of good 1 was 1, price of good 2 was 2, and income was 50. Then plugging into our equation for the budget line, we have Q2 equals Y over P2 minus P1 over P2 times Q1. P2 is 2, P1 is 1, and Y is 50. So simplifying that, we have Q2 is 25 minus a half Q1. So we can plot that. So the vertical intercept is Y over P2, which is 25. The horizontal intercept is 50. And the slope of this line is minus a half. Now, look at these corners here. What do these corners represent? This corner here represents the bundle that you could buy if you only bought good 2. So if you bought only good 2 and You have $50, and if you spend all $50 on good 2, well, you could buy 25 units of it. This corner represents buying only good 1. Again, you've got $50, and if you spend all $50 on a good that costs $1, well, you could buy 50 units of it. So that's why you've got this intercept at 50 and this intercept at 25. Of course, you could split your money anyway between the two goods, and so you get the straight line between them, these two bundles, which is this line here. Any bundle underneath that is one that you can afford. It's a bundle that costs less than 50. So all the bundles in the shaded area are bundles that you can have. So we call this your budget set or your opportunity set. Now this slope is important. Minus P1 over P2 is the rate at which you trade off between purchasing the two goods. So if I want to purchase less of one good and more of the other good, then this is the rate at which I'm going to have to switch between them. That's why we call this the marginal rate of transformation between goods 1 and 2. So as in the example we saw, if the price of good 1 is 1 and the price of good 2 is 2, then the marginal rate of transformation is going to be negative 1/2. So to get one more unit of good 1, you need to give up 1/2 unit of good 2.